A man starts searching for engagement rings on his phone. He visits a few jewelry websites, compares styles, and closes the tabs, thinking the surprise is still safe. A few hours later, his partner starts seeing engagement ring ads on her phone. He never touched her phone. She never searched for rings, but the two of them share a home, a Wi-Fi network, location histories, contacts, and daily patterns that advertising systems use to link people together. The proposal time and place might still be a surprise, but the ad network already figured it out and unintentionally leaked the plan. It feels like your phone is reading your mind or listening to your conversations, but it doesn't need to. Small pieces of ordinary activity are constantly collected through websites, apps, devices, purchases, public records, and even the people around you. When those signals are connected, they create a surprisingly detailed profile of who you are, what you want, and what you're about to do next. I'm Kristen, I'm a software engineer. I spent my career building systems, and now I help you look beneath the surface of everyday technology to understand how it works, how it affects us, and how we can use it more intentionally. And today, beyond the obvious information we post about ourselves, we're going to look at 6 less visible ways data can enter the data economy through websites, apps, devices, public records, purchases, and even the activity of the people around us. The first place your data can leak is the website itself, through invisible scripts running behind the page you actually see. To see how this works in real time, I ran a scan using Blacklight, an open source web privacy inspector built by The Markup. I added the link in the description if you want to test your own favorite websites along with me. Let's look at what this scan actually uncovered. First, Blacklight flagged 7 advertising trackers. An ad tracker is a small piece of JavaScript embedded directly into a website's code that listens for what you do, like clicking a button, viewing an item, or adding a product to your cart. When you look at a sweater on Target, that embedded script fires an invisible HTTPS request straight to an outside server, belonging to companies like Google, Meta, or Adobe. It doesn't just say a user is here, it sends an event payload containing the exact product ID, page category, and browser specs. When I click the sweater, the embedded script could send an event to the advertising network saying that this browser viewed or clicked a woman's sweater. That request may also include the page address, product category or ID, the time of the action, device and browser details, page I came from, and a cookie or advertising identifier that helps the network recognize the same browser later. The click itself is only one piece. That identifier is what can connect that click to an earlier or future activity. Which leads us into what's next on our Blacklight results. 3 third-party cookies. To understand what that means, let's start with a normal first-party cookie. For example, Target might place a cookie in my browser so it can remember what is in my cart, keep me signed in, or save my preferences when I return. The cookie may contain a simple identifier such as cookie ID 48391. The detailed information usually is not stored in the cookie itself. Target may keep that information on its own database. For example, ID 48391 has a sweater in the cart. When my browser returns to Target, it sends the cookie back, allowing Target to recognize the same browser and retrieve the saved cart. That is a first-party cookie because it belongs to the website I intentionally visited. A third-party cookie begins in a similar way, but this time another company is embedded in the page. When I visit Target, Target may load advertising or analytics code from an outside network. My browser then contacts that outside company directly. The ad network can tell my browser to save its own cookie separate from Target's cookie. So my browser may now hold 2 identifiers, one from Target and one from the ad network. When the tracking code reports that I viewed a woman's sweater, my browser may send the ad network cookie along with that event. Now I visit a completely different website, like a news site. That site also loads advertising code from the same network. Because my browser already has that network's cookie saved, it sends the same identifier back. The ad network can recognize this is the same browser that viewed the woman's sweater earlier. It may record more information about this new visit. It may also use the earlier sweater activity to decide which ad to send back to the page. So the same connection works in both directions. The ad network can collect another event, and it can use the profile it already built to choose the next ad I see. Blacklight also detected canvas fingerprinting on this page. Unlike a cookie, fingerprinting does not need to place a stored ID inside my browser. It looks at characteristics of my browser and devices and uses those signals to try to recognize it again. That is important enough to be its own leak path, so I'm going to come back to it in a moment and test it on my own browser. The last thing BlackRock detected was a full story, a session recording tool that can capture how someone moves through a website, where they click, how far they scroll, which parts of the page they pause on, and where they abandon a process. Again, that can have a legitimate purpose. A company may use it to find broken checkout flows or understand why customers are getting stuck. But when you combine advertising trackers, cookies, fingerprinting, and session recording, a simple shopping visit can generate a surprisingly detailed picture of both what you looked at and how you behaved while looking at it. And that brings me to an important comparison. One of the companies I scanned while working on this video was Salt & Stone, a body care brand. Blacklight detected 0 ad trackers or fingerprinting scripts during that scan. The point being that aggressive tracking is not a technical requirement for running an online store. Companies can choose lighter, more privacy-respecting systems. We know that personal data can be shared, licensed, or sold throughout the wider data economy. But this scan does not prove the target is selling that information. What it does show is that the website has loaded tools capable of collecting detailed information about my browser, device, and behavior. To know what happens after collection, we would need to examine the company's privacy policy, vendor agreements, and actual data sharing practices. Earlier, Blacklight detected canvas fingerprinting on the target page. Now let's look more closely at what that actually means. You might think, I cleared my cookies, logged out, and used a different email, so I'm starting fresh. Not necessarily. As browsers have started blocking more third-party cookies, some companies have turned to fingerprinting as another way to recognize the device. Instead of saving one ID inside my browser, fingerprinting examines a combination of details about my machine. A script quietly asks my browser to render a hidden two-dimensional graphic. Small differences in graphics hardware, fonts, operating system, browser, and display drivers can cause the image to render slightly differently, just like a fingerprint. The script converts the result into a value that can be compared with later visits. I'm going to test my browser using the Electronic Frontier Foundation's Cover Your Tracks tool. I've also put that in the description for anyone who would like to try it out themselves. It examines signals such as my screen size, browser version, operating system, language, time zone, installed fonts, graphics settings, and other browser characteristics. My browser's fingerprint appeared unique among more than 321,000 browsers tested. The strongest signals were not things like my name or my email. They were technical details. My WebGL and canvas rendering, screen size, browser version, graphics hardware, installed fonts, and time zone. Some of those details are common by themselves. Lots of people use Windows, lots of people live in the Pacific time zone. But other signals were much rarer. My particular WebGL result appeared in roughly 1 out of every 1,087 browsers tested. My graphics renderer appeared in about 1 out of 726. So the system's not saying this one detail proves who Kristen is. It's saying that this exact combination of browser hardware, graphics behavior, fonts, screen, and location signals looks different from nearly everyone else that we tested. And then there is one important caveat here. Fingerprinting is not always used for advertising. It can help detect bots, stop account fraud, recognize suspicious logins, or prevent repeated abuse of service. But the same technology can also be used less transparently to recognize a device across visits, connecting browsing activity without a traditional cookie, or continue identifying someone after they intentionally deleted or blocked tracking identifiers. When an app asks for access to my location, contacts, photos, microphone, or calendar, that permission is not just a label in my settings. It's Technically, it gives the app access to specific operating system tools called APIs. For example, when I grant an app access to my contacts, I'm allowing it to request information from the phone's Contacts API. The operating system checks that permission. If access is allowed, the app can read permitted fields from my address book, such as name, phone numbers, and email addresses. That information does not automatically leave the phone just because permission was granted, but the app's code can choose to process it locally or send select contact data through an encrypted internet request to the company's servers. Granting an app access to your contacts does not automatically mean every app uploads your entire address book. Some apps use contact information only on the device, but other apps do upload contact information to their servers for features such as finding friends, matching accounts, sending invitations, analytics, or building recommendations. And from the permission screen alone, those two situations can look exactly the same. Both apps may ask, allow access to your contacts? Okay, so this is where the fine print matters. The app's privacy description, contact sync settings, and privacy policy should explain whether the data stays on the device, is uploaded to company servers, is shared with service providers, or is retained after you turn the feature off. The fourth leak path is public records. Not all personal data begins with an app or a website. Property records, business filings, professional licenses, court records, campaign donations, and some voter information are created for legal or civic purposes. But once those records are digitized, they can be copied, scraped, purchased, and combined. So even if I never post my address online, it may already exist in the public data infrastructure beneath the internet. The original record may have been public for one specific reason. The broker's value comes from collecting it and connecting it to everything else. The fifth leak path is what we buy. When I enter my phone number for a grocery discount, scan a loyalty card, use a store app, or pay with the same credit card, the store may be able to connect that transaction to a recurring customer profile. The full card number does not necessarily need to be stored. Payment systems often use a token or another account reference, but that can still help the retailer recognize that the same payment method has returned. That means the receipt is no longer just an anonymous list of products. It may be connected to a phone number, email address, app account, loyalty ID, or a reoccurring credit card payment. And a receipt does not need to contain one dramatic secret to become revealing. Over time, those purchases form patterns. A pattern may suggest a new pet, a pregnancy, a health concern, a move, a dietary change, financial pressure. The store may use that information internally for inventory, personalized coupons, recommendations, fraud prevention, or advertising. But depending on policies and partnerships, it may also share some information with service providers, advertising partners, or other commercial data companies. Once purchase information is linked into an identifier such as a phone number, email address, loyalty account, or payment token, it can potentially be matched with other records tied to that same person. The final leak path may be the most frustrating because it does not begin with something you chose to share. It begins with other people. A family member takes a group photo at your house and uploads it. They may not realize that that original file can contain metadata such as the date, time, device information, and in some cases, the GPS coordinates where the photo was taken. But even if the location metadata is removed, the image itself still contains information. Your face may be visible, so may your home, your child's school uniform, a street sign, a workplace badge, the people standing beside you, or details that reveal where the photo was taken. And you don't necessarily need to be tagged for your face to be detected. We already see this technology on our own phone libraries. Apple Photos recognizes faces and groups images of the same person together. Google Photos similarly creates face groups so that similar faces can be searched and labeled. That means the system can first detect an unknown face, generate a mathematical representation of its features, and group it with other photos containing a similar looking face. At that stage, the system may not know the person's name. It may only know that this appears to be the same person in these 12 photos. But even if one of the photos is later connected to a name, account, contact, event, or tagged image, the other untagged photos may become easier to associate with the same identity. Most of the time, the person uploading the photo is not trying to expose anyone. They're sharing a memory, organizing an album, or posting something they thought was harmless. So this is not about blaming people for sharing. The real problem is that social media companies often made the collection confusing, buried important settings, and presented ongoing access as something far more harmless than it was. Meaningful consent requires more than an allow button and a privacy policy designed not to be read. And that's the point of this series, not shame or panic, just a clearer view of the systems operating behind our ordinary choices. There are practical ways to reduce some of this collection. I'm going to dedicate an upcoming episode to test these solutions more carefully, what they block, what they miss, and which changes actually make a difference. But first, we need to follow the data a little bit further. In the next episode, I'm going to build an identity graph around a person who does not exist and show how data brokers can take scattered details, devices, addresses, purchases, relationships, and online behavior and connect them into one identity. Then, in the episode after that, we'll follow the profile into more powerful systems and look at how connected data can be used, who benefits from it, and what happens when those systems begin influencing real decisions. And since you made it this far, I also want to officially welcome you to the first season of Clean Build Studio. Up until now, I've mostly followed my curiosity, making videos whenever I tested a tool, noticed something strange, or found a system I wanted to understand more deeply. This season, those ideas are coming together in two connected series. In one, I'll continue building and testing local AI systems to see what these tools can actually do beyond the marketing, and whether keeping more of our technology local can give us greater privacy control and independence. And in Behind the System, we'll examine the technologies already shaping our lives, how they work beneath the interface, what they collect, and what happens once those systems grow larger than any one person can see. Some of you have already been watching the earlier videos I created about tracking, face filters, privacy, and the way AI is being pushed into everyday life. I was not calling those videos a series yet, but they were really the beginning of this one. Thank you for being here at the beginning of this season and for being curious about what's happening beneath the tools we use every day. I'm Kristen, and this is Clean Build Studio. I'll see you next time.